Let's study the atomic theories in this video. We already know that an atom is the smallest particle of an element. We already know that this atom is coined from a Greek word called atomos by a scientist called Democritus. This atomos is a Greek word which means that something that is too small that cannot be divided. Now, what brought about atomic theories? There's a question: how do atoms look like? What are the composition of atoms? What are those particles that are embedded in an atom? And is it true that atom is the smallest particle that cannot be divided? We can't find answer to this question until we study the atomic theory. The first scientist to first put forward the atomic theory is called the John Dalton. His name is John Dalton. Okay, so let's look at the Dalton atomic theory and let's look at the understanding in this video. And also I will discuss the modification right here. Now let's go. The first one is that all elements are made up of small indivisible particles called atoms. See, the word indivisible here is what we should take note of according to John Dalton. He proposed that what atom is the smallest particle that cannot be divided. That's the meaning of this word. It cannot be divided, it's too small. Okay, let's go to the next one. Atoms can neither be created nor destroyed. Yeah, it's telling us that well, there's no process that can be used to create or destroy an atom. The next one, an atom of the same element are exactly alike and differ from atoms of other elements. Let me explain this. Let me explain that. Let me say I have a mother M, and give birth to two children, X and Y. It's telling that well, these two children are totally alike in all aspects. It's telling that well, atoms of the same element are identical in all aspects. That's the meaning of this word. Next one, he proposed that what when atoms combine with other atoms, they do so in simple whole number ratio. For example, you see, let me tell you something. John Dalton proposed this statement when he was studying simple inorganic compound like HCl, where the ratio of hydrogen to chlorine here is 1:1. Also, let me say H2SO4, where we have 2:1:4. Next, where we have Na2CO3, where we have 2:1:3. He proposed this theory when he was studying simple inorganic compound, and he arrived at what they combine to form compound in simple number ratio, just as we have here. Next, all chemical changes result from the combination or separation of atoms. It means that when chemical change happens, it's either atoms combine or they separate from one another. That's the atomic theory. Now, we know that what science keep advancing every time, and this theory, we found some flaws in it because these do not obey the modern atomic theory, like the modern discovery about atoms. So let's see the modification. The first one, he said that what all elements are made up of a small indivisible particle called atom. You see, we later discovered that atoms still contain some subatomic particles, which we will study in this video and their discovery in detail. So if this can have subatomic particle, it means that it cannot be the smallest indivisible particle. So we can just say that what an atom is the smallest particle and it can be divided into proton, electron, and neutron. It can be divided into pen, proton, electron, and neutron. That is the concept. Next, atoms can neither be created nor destroyed. You see, the only problem with this theory is that what in chemical reaction, it is very possible atoms can neither be created nor destroyed, correct? But what of nuclear reaction? So it did not state that in chemical reactions, atoms can neither be created nor destroyed. This will have been correct. But what of nuclear reaction? Where we study nuclear fission and fusion, atoms are created, atoms are destroyed. So we can say that here in nuclear reactions, atoms are created and destroyed. Next, atoms of the same element are exactly alike and are different from atoms of other elements. In this video, if you look at the description box below, I dropped a link where you are going to watch the video about what isotopes. You see, isotopes are atoms of the same element. Let me look at them. Look at them. Cl. Let me say I have this 37. Look at this. These are atoms of the same element, chlorine. These are atoms of chlorine. You observe that they have the same atomic number but different mass number. See, for them to have different mass number, it means that they cannot be alike in all aspects, and that is it. Take note of that. Next, when atoms combine with other atoms, they do so in simple number ratio. Like I said earlier, This man proposed this theory when he was studying simple inorganic compound like HNO3, H2SO4, this simple inorganic compound like NaCl. But what happened? He forgot. When you see, he did not study some complex molecule in organic compound, like let me say maltose, where we have C12, H22, O11, where we have starch, which like about thousands of molecules, where we have fat and oil, where we have what? Atoms combine to form what? To form compound, not in simple number ratio. Look at it, this is 12 ratio, 22 to ratio 11. This is never a simple number ratio. So in organic compound, they don't form compound in simple number ratio. Okay, it's large number ratio. Now, this 5 is the only atomic theory that still stands to today. So if you are being asked that which of them is not being modified, still stands to today, is still what? Number 5. Because when chemical change happen, it's either they come atoms combine or they separate. So that's about that. So let's move to the next one. Let's look at the subatomic particles. You know what are subatomic particles? They are those particles that are found in what? In atoms. Now, the first one we are going to be learning is how electrons are discovered. Now, you see, the first one here we are going to be discussing is the Crookes experiment. You see, this apparatus, we call this Crookes tube or discharge tube. This experiment was first conducted by William Crook. This is named William what? William Crook. Good. Now, what happens? See, you see, this tube that we have here contains gases at a very low pressure. You can see it's not just low pressure, very low pressure. And again, in this tube, we have what voltage that is being supplied, a very high voltage. That is a past high voltage to gases at low pressure. Then what happened? He observed some stream of particles that travel from the cathode down to the anode. And we name these particles cathode rays. Again, when it passed high voltage to gases at low pressure, he observed some stream of particles that travel from the word cathode to the anode, and he called them the word cathode rays. They are called cathode rays because what? They originate from the cathode and move towards the what? Towards the anode. That is the word. That is the cathode ray. You see, this experiment was first performed by what? By William Crook. So the founder of cathode ray is who? William Crook. Exactly. But also, if you look at the work of J.J. Thomson, you see the discovery of electron are both attributed to what? Crook and what? J.J. Thomson. But who started the work? William Crook. Now, what happens here? You see, J.J. Thomson studied the property of cathode ray further. What happened? He exposed them to what? To electric field. And he observed that what? Cathode rays were deflected towards the positive plate. You see, we don't know the charge of cathode ray before, whether it's positive or negative. No. What happened? He exposed them to what? To electric field. Let me say we have positive here and we have negative here. And what happened? Cathode ray were deflecting towards positive plate. Now remember, unlike charges we attract, since this is positive, if anything deflect towards the positive, it means that the charge of that particle is negative. So that's how we're able to know. Similarly, J.J. Thomson went ahead to determine the charge to mass ratio of cathode rays. What the charge to mass ratio of cathode is approximately 1.759 times 10 raised to power 11 coulomb per kg. Exactly. He discovered the charge to mass ratio of what? Of cathode. And take note of something. This charge to mass ratio do not depend on any factor. What am I saying? This value here is constant irrespective of the gas you are using in this tube, irrespective of the material you are using to what? You are using as the cathode or the irrespective of the type of metal you are using as the cathode or the anode. It means that the charge to mass ratio is always constant irrespective of those factors listed. Nice. So because of this also, so we can say that the founder of this can be what? Crook and J.J. Thomson. But J.J. Thomson was the first to perform this discharge tube experiment and not J.J. Thomson. Okay. Also, J.J. Thomson was also credited as the founder of what? Of let me say of electron. The thing is that when Crook discovered these charges, we don't call them electron, we call them cathode ray back then. But now, cathode rays has been changed. The name has been changed to what? Electron by a scientist called George Stoney. Exactly. So George Stoney named cathode rays electron. Okay, good. So J.J. Thomson was also credited a discovery just because of his work. He helped to study the effect of electric and magnetic field on cathode ray, and also he helped to calculate the charge to mass ratio of what? Of cathode rays, and this is what we have. So that's that for about that. So that is for it. So two scientists can be credited the founder of what? Of electron. So we can have Crook and J.J. Thomson. But if you have the two in the option, you are going for what? William Crook. That's it. Okay, that's that about that. But before we leave this chapter, let us look at the properties of cathode rays and what we can deduce from the property of cathode rays. Now, what can we deduce from the property of cathode rays? See, firstly, take note that the first property is that cathode rays deflect towards the positive plate in an electric field. And what can you deduce from that statement? You can deduce that cathode rays are negatively charged. That is it. They deflect towards the positive plate in the electric field. Therefore, they are what? Negatively what? Charged. They deflect towards the positive plate and they are negatively what? Charged. That's the first one. Now, the second one is this. If you place a paddle wheel along their path, you see a paddle wheel just like a wheel of, let me say, something that can rotate along their path. What happens if they strike this paddle wheel? They will cause it to rotate. Yes, they can cause what? A paddle wheel to rotate. A paddle wheel placed along their path to what? To rotate. And that shows that what? They have what? They have mass and they possess what? Velocity. It means that what cathode rays have, it means that they have mass and they possess what? Velocity. Remember, in physics, what's mass times velocity? That's what? Momentum. It means that they have momentum. Good. That's what you can deduce from that statement. Nice. Next one is that you see they can also what? They can also penetrate thin sheets of what? Of aluminium. Yeah. They can also what? Penetrate thin sheets of aluminium. So and so on like that. And so on like that. So those are the properties of what? Of cathode rays. And last, one more property is that you see, how do cathode rays travel? Do they travel in a straight line, in a circle, or curved path? How? The thing is that, firstly, you see, if you place an object, let me say I'm placing an object behind this anode, for example. You see, cathode ray can cast shadow of this object. It's just like if you have a torch like this, and this torch, bringing out the light here, and you place an object, you see that you will see the shadow of the object. That is an experiment to show that light travel in a straight line. Because something rectilinear propagation of light. Good. So cathode rays cast shadow of object placed along their path. So it means that cathode rays travel in a straight line. Exactly. Okay. So you can say that cathode rays cast a shadow of objects placed in their paths. So those are the properties of Of cathode rays. So that's that on this chapter. Next, let's look at what before we look at this, take note of something. I would like to tell us something about this. What's that? Okay, let me put it here. You see, I'll put a model here, and that model is Thomson's model. Thomson's model. After those discovery, of course, he went on to propose how the atoms will look like. Remember, the study of atomic structure is like what? How do atoms look like? We need that question. How does it look like? What are the composition of atom? Good. See, he described an atom as a positively charged sphere. A positively charged sphere where electrons are embedded in it. These are electrons, and we have a positively charged sphere like this. Positively charged sphere. Good. I will explain something, a way to remember this model. Okay. This is Thomson's model. What brought about this model? You see, this Thomson's model is called the plumb pudding model. We call it the plumb pudding. The plumb pudding model. Or you see, we are not conversant with this word plumb pudding. I'm sure people don't even know what it's called. But the main word that is very, very common is watermelon. So we can call Thomson model the watermelon model. You see, the reddish fruiting part of that watermelon is this red part. That resembles the positively charged particle. While the seed of those watermelon, those black seed, represents the electron that is dispersed in it. So Thomson's model again proposed that what an atom is a positively charged sphere. Are you there? Where electrons are what are dispersed in it. Okay, and think now this positive charge are what are distributed uniformly across the spheres, and that is according to what Thomson's model. Good. What now happened? Rutherford now put this model into test. Let's see, is it true or not? You see, Rutherford with his students Hans Geiger and Ernest Madsen. Madsen. Good. Pardon me if I missed the spelling. So Ernest Madsen. So good. So what happened? They put this into test. What happened? They picked this gold foil and they bombard a gold foil with alpha particle. That's why we call this experiment alpha scattering experiment. That's the Rutherford experiment. He took a gold foil and bombarded it with alpha particle. You see, according to Thomson's model, if Thomson's model were true, all alpha particles are to pass through without deflection or with infinitesimally small deflection. That the deflection should be so small. But what happened? See, some of them were deflected largely. See, this one was deflected this way. See, this one was very like in a very large angle. Also, this one was even some were even deflected like backward. But most of them were able to pass. But some of them have this strong deflection. And how can these small particles be able to stop a heavy a heavier mass alpha particle? That is not possible. Now this model cannot explain the deflection of this alpha particle. Why? We expected all of them to pass through, but what is stopping what's causing the deflection? So this model can't answer it, can't provide answer. Then what happened? Then Rutherford proposed this theory. He proposed that what an atom consists mostly of an empty space, exactly, with a positively charged center. I will explain this. With a positively charged center where the whole mass of the atom is concentrated, and that is it. An atom is a what? Is an empty space, consists mostly of an empty space, but with a tiny positively charged center, and this center is where the whole mass of the atom was concentrated. Now, this model can answer this question. Those alpha particles that were striking the nucleus, this is where the whole mass of the gold atom is concentrated. This nucleus. Now, those alpha particles that were hitting this nucleus were the ones that were deflecting at a very large angle. It's just like you are running and you mistakenly hit your head on the wall. You know the way you just deflect, or let me say someone were involved in a car accident and the person collided with a big truck. What happened? The person will deflect at a very large angle. So those alpha particles coming in contact with this nucleus were the one that were deflecting at a very large angle. So that is it. And one more thing, Ernest Rutherford also proposed that what the electron keep revolving around the nucleus of the atom, and that's all. So I will summarize that an atom consists of an empty space with a positively charged center where the whole mass of the atom is concentrated. Also, he proposed that the electron keep revolving around the nucleus. That is it. Nice. So this is what the Rutherford model. So that's his proposition all about. So let's go. Chemistry keep on advancing, and what happened? A man came again, and the name of the man is who? Is Niels Bohr. The fact is that there is no perfect atomic structure till today. When one proposes, the other will counter. When one proposes, the other will counter. So that is it. But before I discuss this, we have other scientists also. James Chadwick, but I won't be explaining the experiment here, but I'll tell us the name of the experiment. He discovered the neutron. Okay, the neutron is also embedded in the nucleus of the atom. Okay, good. And what did he do? He bombarded alpha particle with thin sheets of beryllium. That is it. And the question is this. Remember that I said that Rutherford discovered he discovered the nucleus. And he stated that this is the center of the mass of any atom, where the whole mass of the atom is concentrated. Also, he told us, I said the mass of the atom is concentrated in the nucleus, and it told us the charge of the nucleus. The charge of the nucleus is positive. Now, what's making it positive? It stated that the particles that we have in this nucleus are the protons. Now, take note of something. If you were asked that who discovered the nucleus is Ernest Rutherford, we discovered the proton, Ernest Rutherford. Remember, I told us that what we have a positively charged center. What's making it positive is this proton. So he told us that what the charge in the nucleus is positive due to the existence of proton in the nucleus. And also, another particle you will find in the nucleus is the what? Is the neutron. Is the neutron. So it means that what? A nucleus. If you have a nucleus, it has proton. It also have what? Neutron. That's why proton and neutron are called the nuclear particles. Okay, so that's that. Also, the next person I will talk about here is what? Henry Moseley. Henry Moseley. So he told us the amount of proton that can be found in the nucleus, and that's corresponding to the atomic number using his X-ray experiment. Okay, good. That's his contribution about atomic number, and also that means the amount of proton that you see in the nucleus. Next, let's look at our Niels Bohr theory, and this is the one that modified the Rutherford theory. Remember, Rutherford told us that we have a positively charged center, and electron keep revolving around the nucleus of the atom. Okay, this Niels Bohr, of course, is a quantum physicist, and there's a particular theory in the electromagnetic field. That theory says that if a negatively charged particle revolves around a positively charged center, this negatively charged particle will eventually fall into the nucleus and will collapse. Just like I gave you a race that should run around this field 100 times. It will get to a point you might get so exhausted and you might faint. And that's the case of this electron. That when it keeps on revolving around this positive charge, what happens? It will radiate energy. It will what? It will radiate energy up to a point that what? It will fall into the nucleus and it will collapse. Now the thing is that what? The earth has not collapsed. Everything has not collapsed and nothing has collapsed. You see this Rutherford theory also, this Rutherford model is also called the what? The planetary model. The planetary model. The planetary model. That's the word the Rutherford, because it turns out that what, this nucleus is the sun. Why this electron revolve around the nucleus just like the way the planets revolve around the sun. And that's it. So it describes an atom as a solar system. So that's it. So but Niels Bohr is telling us that this electron will radiate energy. It will what? It will give out energy, and the electron will later fall back into the what? Into the nucleus, and the whole atom will collapse. Now the question is, everything has not collapsed. Things are not collapsing. So this Rutherford model cannot explain stability of atom. That's part of the shortcoming. It cannot explain stability of atoms. If you understand this very well, you'll be able to know the shortcomings very well. So it was unable to tell us why are atoms stable. According to your theory, everything should have collapsed. Why are they not collapsing? What's wrong? It cannot explain that. So that's why Rutherford's model is what is ruled out. Then let's look at what Niels Bohr. Now, Niels Bohr just corrected something. Remember, we still have the nucleus that have the proton and neutron. He told us that what the correction of Niels Bohr to concerning Rutherford's theory was that electron revolve around the nucleus, sure, but Niels Bohr proposed that those electrons exist in what? In an orbit. They don't just revolve around the nucleus, they revolve at a certain orbit from the nucleus. And he proposed that the first orbit has a principal quantum number of n equal to 1. The second orbit has a principal quantum number of n equal to 2. That is why principal quantum number is called Bohr's quantum number. So his proposition was that the electron revolve around the nucleus at a certain orbit, which is at a certain distance from the what? From the nucleus. And he proposed that the electron don't radiate energy whenever they are in this what? They are in this orbit. And those orbits, he call them energy level or shells. Good. So when they are in this energy level or shells or orbits, they don't radiate energy, and that is it. And that is it. So that's this proposition. So that electron exist at a certain orbit and they don't radiate energy while in this orbit. Correct. That's it. That's it about what? About Niels Bohr. So I believe the concept is what is very, very clear. So let's see if there are other things for me to explain. Okay, good. Remember I told us that the electron don't radiate energy in this what in this orbit. But what happens? Let me say an electron want to jump from one orbit to the other. Then what will happen? You see, if electron want to jump from lower orbits, if electrons or if there will be electronic transition from lower orbit to what? To higher orbit. If there will be a transition from lower to higher orbit, what happen? See, if you want to jump from a lower point to higher point, I'm giving you a task to jump from here to here. Please, will you need to absorb energy or release your energy? You need to absorb energy. That is why people that are doing high jump, they'll have to run from a far distance, then jump. So what happens? The electron must absorb energy. But what happens from higher orbits to lower orbit, what happen? It will release or radiate energy. That's that about that. So like, comment, share this video to your friends. If you are new to my channel, please click on the subscribe button and notification bell, so when I upload any new video you get notified. It doesn't consume any data, just click the subscribe button. So thanks for watching. Bye.